I'm gonna stop here and then invite the DevOps Nairobi community to just tell you a bit on what they do and how you can sign up to be part of their community.
Okay, thank you, Sasha. So my name is Samuel Kadima, and I'm the founder of Nairobi DevOps community, but we have a number of managers who from the Nairobi DevOps community who ensure that we can be able to engage as a community, network, and collaborate, and also maybe learn from each other. So if there are any in the meeting, maybe I'll give them a second to just say hi. So I think we have, if there is any of them here, Franklin Odd, you can say hi. I think we are not able to hear from Franklin. Yeah, but you can say hi on the chat actually. So if there is any of them here, you can just say hi on the chat. So what I'm going to, if you can move to the next slide. So we just a community of DevOps enthusiasts, and we are focused on innovation, collaboration, and growth. So we have projects that we do on our GitHub projects where people can collaborate on our GitHub projects. And we also ensure that we tell people about DevOps. So people who are not aware of DevOps, or people who are new to DevOps, we expose them to DevOps so that they can see if it's a career they can pursue. And those who are already DevOps engineers, we look for ways to see how they can grow. So we have our community that is composed of people who are DevOps experts and also beginners. So the experts share knowledge with those who are new to the field, and those who are new to the field get the opportunity to learn from the experts. So we conduct weekly sessions. So every Sunday, apart from this week that we're having this event in partnership with Moringa, and other events that we have on Saturday, the rest of the events normally happen on Sundays at 8 p.m. And they are online sessions, the ones that we do on Sunday at 8 p.m. But we also have physical sessions that we do in partnership with Moringa as well. So the events are just an opportunity for people to network and learn from each other. So you can move to the next slide. So our mission is just to create a supportive and inclusive community that values diversity and supports learning and growth. And then you can move to the next slide. Our vision is to be a leading DevOps community in Nairobi and beyond, driving innovation and empowering professionals to excel in their careers. So if you want to join our community, you can move to the next slide. So you can scan the code on the screen. So you can join the LinkedIn, WhatsApp, Twitter, or Discord. So you can just scan any of these, and then you'll be able to join the community. And from there, you'll be able to learn about our events and also get to see what other people are sharing about what they're learning about DevOps or what the articles they have written, or anything that can help you, or opportunities as well. So that is about Nairobi DevOps community. I think we can just leave this for 30 seconds for people to scan, and then we proceed. So we also have, we are also planning mentorship. So we started in April, but we're also planning mentorships to connect new beginners to people who are already experienced in the field, so that they can mentor them in their career as well. So that is it about the community. So I think you can proceed, Sasha.
Okay, thank you so much, Samuel. Maybe we can take one or two questions for you before we invite Albert.
Okay.
All right. Does anyone have any questions for the DevOps Nairobi community before we proceed to the workshop? And feel free to unmute yourself. You can unmute yourself and yeah, we'll answer. Okay, I'm just seeing questions for Moringa. Maybe my team can help me answer Chiri and Dorcas on the chat box. Any questions for the DevOps? Have you been able to scan and join? Please confirm.
Excuse me.
Okay, yes.
Hi, good morning, everyone. My name is George, and I have a question to the DevOps community. You said you have usually have physical classes for the group from Moringa. Is it only for the Moringa group, or is open to everyone? Thank you.
So what we have, they are just physical sessions, and these physical sessions are workshops. Mostly they are workshops on DevOps tools, just to expose people in the community on all the DevOps ecosystem, and all the sessions are free. So it's just that we do it in partnership with Moringa. We do them at Moringa School, but anyone can attend and learn about DevOps. If you're interested in becoming a DevOps engineer, you can attend the session, and all sessions are free as well. I hope I've answered you.
Yes.
Again,
yes.
When are the sessions open? Or you communicate on platforms?
Yeah, so if you join our community, we normally share the upcoming events. And so far every week, so even next week, you're going to have an online event on Sunday. It's going to be on a topic called Istio. And it will be presented by a senior DevOps engineer. So you can just join the community, and we'll be sharing that. Maybe by Tuesday, the poster will be out, and you guys will be able to see it.
Okay.
So to join, I can see here, I can see Malcolm asked how to join. To join, did you mean the DevOps community or DevOps course? No, so if it's the DevOps community.
He's asking for a link because he can't scan.
Oh, okay. So let me share the links then.
Okay, great. All right. If you'd like to sign up for the Moringa courses, specifically the DevOps engineering program, will also be sharing a link with you on the screen, but I'll come back later on to take you through what we offer, what is covered in our course, and yeah, I'll answer more questions around that later on. At this point, let's get to the main part, the main reason why we are all here, to learn more about cloud computing and how this maps out, or how this is integrated in DevOps engineering, right? Why is this important for you to learn if you're on your pathway to becoming a DevOps engineer? Yeah, so I'll welcome Albert to take us through this session.
All right, thank you. Could you please confirm if you're able to hear me?
We can hear you.
Okay, thank you. Just allow me to share my video, which I can work this time. Sorry, still experiencing the same challenge, but no worries. We can just proceed. All right. Will you allow me to share my screen, or do you love to continue sharing the slides?
No, you can share the screen.
All right. Just a second. Okay. Maybe if you will help me in here, just share, and then when everything comes to okay, I will share. Could you please move to the next slide? I'm having a challenge on my end. Continue sharing yours. Let's use your screen.
Okay. Samuel, are you able to share on your end? And just help me coordinate. Samuel?
Okay, I see. I can snatch a screen.
Okay, just a second. Let me try and share.
Okay.
Let me share. I'm now able. Let me snatch the screen away.
Okay.
There's a number of issues there. And let me know if you're able to see my screen.
Okay, we are good now.
Okay, so just confirm which you are able to see the introduction slider. The first, my profile slider, that's okay?
Yes, it's okay. We can see the screen. Is everyone else able to see the screen? Please confirm on the chat box.
Yes, we are.
Thank you. First of all, just an introduction. My name is Albert Sitati. I'm currently a Microsoft Azure Cloud Architect at BOI. What that entails is I normally help clients, and in this case organizations, to achieve a smooth transition to cloud, and also to help cloud meet their business goals, both organizational goal and also their cloud strategy. I'm also a Microsoft certified associate and also a Microsoft certified cloud solutions architect. And I love everything about cloud computing. So I would love this one to be an interactive session. I'll be posing after each presentation. You are welcome to ask as many questions as you can. I'm here to answer as many questions as we can during this particular session. I'm also a member of Resource Cloud Academy, among the co-founders, whereby just like what the Nairobi DevOps community does, we also enthusiasts of cloud. We discuss all things about cloud and how we can use cloud in our daily moves. Okay, allow me to jump into it. As I've said, feel free to drop a question, pause, unmute, ask. We are here to learn. All right. So as we start, allow me to take you through a journey. We have two kind of a journey here. The first journey is we are moving from rural to urban. You are migrating just the same way when the migration was happening a long time ago, rural urban migration. And a good case in this case is probably when you're joining your tertiary levels of education, you're moving from your high school to campus. In this case, there are two things that can come in your mind. The first of all, we want to look in a way in which you can come and have accommodation, the way you can accommodate yourself. The first thing you'll think about is you are moving from rural, you're coming to maybe town. In this case, let me use Nairobi. Are you going to buy land? Are you going to construct that building that you live in? Or rather, you will come there and take a rent just for the time that you want to use. And when you're through your education, you move away. Probably you relocate where you'll get a job. The other journey is that maybe you have a lot of money. Suppose you have this money that you can buy land, you can build, and also to accommodate yourself over this period. But will that be an essential decision that you truly want to make? Probably you will all agree with me. The answer will be no. For the first case, you are from your high school, you are coming to maybe town for your tertiary education. I bet all will agree the best choice for us, you come there, you will rent a building, a room, be it a bed-sitter, one bedroom, whichever case that will be. And then you will stay there for just the period that you need, paying just for what you're using. And then after the end of that 4, 3, 5-year course that you will be taking, you move away from it. Just the same way as cloud it is. Your business, you're coming to cloud. You don't want to build that building, that server room, that data center. You all have all those resources in there. A good choice maybe it can be, you just go to someone who already has this platform built for you. You're just renting there some space. You're just using for the period that you want to use. And then after you're complete, you come back. So that was the first journey. The next journey, it was when you had a lot of money. So you have money, Yeah, we don't disagree with that. You have money, you can buy land, you can build, and you can stay there for 5 years. And at the end of these 5 years, are you going to demolish this structure that you had constructed? A good bet, we'll all agree, it will be that even if I have money, but I want to be there just for a specific time. And I also want to be up to speed, because you try to see the time that it will take you to buy land, do all those negotiations, build there for you to stay. It will be much time. But a case in mind here, we have speed is something of key interest in this case. So in such a case, when you compare business, you have the capability, you can maybe construct the building there. But in this case, you won't want to go down that path. We have time to the market. We really need to get faster time to the market. So in this case, we'll choose, okay, then this can be a good idea. Rather than me as a business, I set up this structure that we call it data center and have all these servers in my room. I'll choose that. Let me go to someone who has already do that for me. And let me just take a portion that I will want and let me deliver what services I want to deliver to my customer. So those are two journeys that you can consider to try to picture what cloud really is. Allow me to move on. In this second slide, I want us to consider this scenario. Maybe you are an owner of a software engineering company, or maybe just any organization. Over the years, you have been in operation, but at this particular point, you want to scale out, you want to grow, because what happens? We are getting more people. Maybe in this case, like for the Nairobi DevOps community, in this case, after this, we're going to have many members as you have shared the link. So that brings in the aspect of scalability. Are we able, as the owner of the organization, will you be able to scale? So some of the questions will ring in your mind. For example, one, I have a small team. My team is small. When I expand this organization, will this team be able to manage it for me? Other questions it will be, you don't know, maybe at this particular point, high traffic. Okay, can you help me moderate on the other end? Thank you so much for that. So the other question it will be, you're suffering from unpredictability of demand. You don't know maybe what will happen 5 years ago. You don't know. You just have a view of this short term. Another thing that can be a very thing to consider is your financial constraint. Are you able to scale? Yes, we have agreed that the demand has gone up. You have more customers. You feel there's a need for you to expand your structures, but do you have the financial capability to do so? So that's also a question that you as a business owner, you will consider. Another thing is, will I have visibility into my business operations? These are questions of, do you have visibility? Are you able to monitor? Suppose you're having various branches, your business, you want to expand. First of all, you started out in Nairobi. You want to have branches maybe at Coast, Kisumu, Eldoret, and name a place that you love. Will you be able to have visibilities over all these branches in terms of how you manage them? The other thing that you may consider, and this will really be great, is how will you ensure that your environment is secure? As recently, we are having a lot of issues with security. How will you ensure that as you expand, first of all, you are a very small organization. Just one, maybe a firewall could really serve you, because people are coming from maybe the main branch alone, and that you could easily monitor your traffic, and also you could easily control how your traffic is reaching the internet. But this time, you want to have branches all over the country, all over the world, all over the globe. The questions of security comes in. How will you make people authenticate into your environment? How will you have visibility over this traffic that is going to the cloud? So by that, you feel this won't work. You feel that if I consider all these things, me setting up this physical environment there, that won't work. And that is exactly where the cloud comes in. So the cloud comes in that you will not need to manage these resources, because a cloud provider will provide for you a team that will look after these resources. When you provision your resource in cloud, the cloud is being managed by experts behind the scene, and those are the ones who are going to take care of this environment. So the question about having a small team, it's no longer be something of your stress. We normally choose the stress that we want. So that's not your stress. Your financial constant. I'm not going there for capital expense. I want to go with the variable expense. I don't want to maybe set that I'm going to spend this amount of money in buying server, yet you don't know if that server will be in operation over this time that you're going to buy. So you want to have a model whereby you just pay only for what you are going to consume. What about visibility? The cloud brings many capabilities in which you'll be able to have visibility, or you'll be able to have full visibility over your operations. Just to mention, when you come to Azure, you'll deal with the Azure Monitor. Together with other very powerful tools, it will be able for you to have visibility over your traffic, over how people are authenticating into your resources, on how your resources is scaling, whether you need to scale up or scale down. All these metrics, be it logs, you'll have visibility over them. And then when it comes to security, a lot of these cloud providers spend a lot of money in security. For it, just to mention, for example, Microsoft has a budget of $1 billion on a financial year that spends in security. So it is really investing in security. This security varies. It varies from the identity security. It varies to application security. It varies to network securities. They ensure that they provide you with these all tools that will enable you to have a secure environment. And as we all know, or maybe just to bring to your attention, when we come to cloud, security is a shared responsibility. As a cloud provider, which I'll later tackle later, as a cloud provider, the cloud provider will provide you with the tools. In this case, they will provide you with the tools that will help that you have to use to enforce, to have a good security posture. And so the question of security, it will no longer be much of your stress. However, there's some aspect of you have to play for you to have a very secure environment. What about unpredictability of demand? Take an example of an application that you're more used to. Let's say Jumia. Jumia, during maybe holidays, during Black Fridays, what do you expect? We expect that the traffic will be high. The number of people visiting these sites, it will be very high. And we don't want our application to suffer from DDoS attack, whereby a lot of people are sending requests than our application can sustain. So in this case, we need to scale up so that we can allow room for more traffic. What happens when we are not in holidays when we are at the low seasons? There is no peak, low peaks. So what happens there? You don't want to just continue to pay for what you are not using. You want to scale down so that your application can just handle the small traffic that comes in there, and you reduce on the cost that you are going to use at that particular time. And that's what brings in the concept of cloud. With this cloud, it will help you to have at least a predictable demand, and on how you're provisioning your resources, be it your provisioning infrastructure, be it your provisioning your applications, your database, just name it. And that brings us to the definition of what really this cloud is. I've taken you through a journey. I've shown you 2 ways that you can do it. We have taken you through a journey for that person who has not enough resources, how you can move to cloud. Also, how this is relevant to someone who has a lot of resources, but cloud is still viable to them. I've also taken you through some of the things that will make this concept of cloud relevant to you, some of the things that you need to consider. So I know at this point you might be asking yourself, then, what is this cloud computing? By definition, we define cloud computing as the on-demand delivery of IT services, cloud computing services on a pay-as-you-go model. And this is provision over the internet. When I talk about the IT services or these computing services, we are talking about storage. We are talking about, when we say storage, you're also talking about our databases. You're also talking about our network. Just name it. A lot of these resources, they're just being provisioned to you over the internet on a pay-as-you-go model. Pay-as-you-go model, you only pay for what you need. When that time elapse, you cease paying. So at that point, that is cloud computing. If you feel you have any question about specifically the slide that I've shared, just feel free to unmute, seek for more clarification as I continue. Okay. All right. Okay, so I believe at this juncture, we have had a lot of definition on cloud computing. People saying, what is cloud computing? Others saying that cloud computing is like someone's computer, whereby you're just using someone's computer. I would love to challenge that by saying, in as much as it's someone's computer, it can be a cloud. When you talk about cloud is more of someone's computer plus network, because it is through this network that you're able to access these resources. Yeah, it is a billing somewhere. In that, the only difference is that you're not the one who is owning the billing, but it's just a billing somewhere that maybe you could have money, you could just have the same billing, where we have applications running on those billing, because we have a lot of servers in them. These buildings, they have a lot of servers that can be used to store data, because they're going to use storage there. Also, these buildings are going to host our websites, our applications that we want to be, it will all be in that building. A good example is when you talk about cloud, I can say it is AWS, Amazon Web Service. That we all know that is an e-commerce site, but it is sitting under the owner is the Amazon, who are the owner of AWS. So all these resources, they are running inside them. They are very, very, very huge data centers. And these data centers, they are distributed all over the countries. Not all countries or all regions have these data centers, but in a strategic positions. And the way that we do on how these buildings are distributed, there's a hierarchy that is followed. We have the availability zones, and then we have data centers in, and then, we have regions first. First, how will this region be? A region, it's just, we can say it's a geographical locations whereby it has a lot of availability zones. We can have, maybe you've heard about East-US region, we can have very close to us, we have South Africa North region. So these are just geographical locations whereby we have a lot of these, the availability zones are there. That begs the question, what is this availability zone? So when we talk about the availability zone, inside these availability zones, we have multiple data centers, because we want to ensure that there is business continuity, in that when there's a downtime or disaster happening at my primary region, suppose this is an earthquake or any disaster that can happen on my primary region, I should be able to continue running, whereby my services are being migrated, or they fail over to my next data centers. And that's why under availability zones, it contains multiple data centers in an availability zone. And then a data center is just this building whereby we have these servers, that runs our applications, we store our data, and anything that you can think of, it is under these data centers. Maybe at that point, I would love to welcome a question. We have any questions so far? Okay, I believe not. Okay, thank you for that. So that begs the question, who owns these buildings? Suppose I'm having these buildings where we have these server runs that host our application. Who owns these buildings? So the owners of these buildings are the ones who are called cloud providers. I know we have heard about numbers of cloud providers. We have AWS, Amazon Web Service. We have Microsoft offering as Azure. We have Google Cloud. You have heard about Alibaba, Nutanix, just name them. There are a lot of cloud providers, but the major three in the industry is the AWS, is the Azure, and is the Google Cloud. So these are the owners of these buildings. They're the one who constructed these buildings. They're the one who ensure that there are various services into these buildings that can enable businesses, individuals, organizations be able to rent or use some of these services that they provide to them. Allow me to move to the next. So what happened long before cloud? And because, with Amazon being rolled out in some time around, I believe 2006, 2008, that period, Azure coming into play around 2013, and then having Google Cloud. So what happened before that? So let us try to go through a journey. For those who are able to work a long time ago, whereby you are provisioning servers so that you can run, you are mostly into data centers whereby you had to provision a server. The process was very tedious because suppose we just want to set, we want just to set our lab test environment. In this case, maybe to use for emailing and other purposes. You could write a letter to the procurement department. You want to procure a server. The procurement department has to validate that your need is really valid so that you can procure these servers. And these servers are used to be shipped. And before these servers come, there's that time. It's not something that you can order today, it comes tomorrow. Normally, before time of shipment, it usually takes something like 6 months. So it could take almost 6 months for this server to come. Making it worse, some time back, you could have to make orders of various components of the server. The server could not come as one rack stuck with everything. No, you had to maybe make an order of a rack from somewhere. You had to make an order of a RAM from somewhere. Then when it comes, you have to compose all these things so that it can become a fully functioning server. Then after that, because this server we want to use for email, we want to install a relevant OS. Let's take an example, we want a Windows Exchange server. So we have to install Windows Exchange server 20-something into it. Because it's old, let us go with 2012. You have to install a Windows Server Exchange 2012 in that server. You go into the process of installation. We all know how tedious the process could be. You have to download the image. You have to import the image into your server. You have to run and provision some resources. And either these resources will take maybe a higher amount of resources. So you have to provision it with a number of CPUs, a number of RAM, a number of storage. And then you come to the real stress now. You are making the configuration. Because this one server is to be used for your emailing, you want to configure your domain. You also want to configure how routing of those emails will go. You have to configure the various protocol like MSTP, you want to configure the various protocols there. You have to ensure that you get the correct port number so that the routing of your emails could go as expected. And then finally, after you've done so, now you're able to send an email. Just imagine that process. How long has this process taken you for you just to be able to send an email? So roughly you're talking something like 8 months or so, you setting up a fully functional server, you configuring it right way for you to be able to send out an email, for you to be able to have a test environment whereby when you develop your applications, you need to test, want to a test environment, maybe some test environment that you can juggle with before moving your applications to production. You see all those processes that people could go. And the bad thing about it came to the configuration. I know maybe we're engineers, we love to get our hands dirty, but do you really want to go stress of you configuring the networking, you configuring the storage, you configuring, virtualizing the environment? Either you have to make a decision, am I going with Hyper-V or VMware? Are we going to install the OS? Are we going to do the patching? Are we going to install the runtime? Are we going to install the middleware? Are we going to install the data into this server? Are we going to install the application? So that begs us the question, like you just an IT there, your end goal was to send an email. Why not just create a Gmail account? Something that can take you less than a minute, maybe if you're lazy enough, can take you something like 5 minutes for you to send an email. You just go there, you just create an email and you just send. So you can imagine what cloud has done, just moving us from 8 months for you just to send an email to something like a 5 minutes, because in 5 minutes, I believe you'll have set up your Gmail profile is there. You're able to send an email. If it comes to Outlook, we're using Microsoft 365, just something like just logging into your Outlook with your one single sign-on credentials, and you're able directly send an email. So that's what the Power Cloud is able to do, really cutting down on time that we need for us to achieve our goal, both for individual, for organizations, and also for the businesses. And this begs the question, and email is just one service. What about other services? What about YouTube? What about databases? What about our web servers? The stress could go on and on. Just imagine. And it was really advisable that, like in a server, you cannot have, just for the purpose of segregation, you cannot have maybe multiple services running on one server. So it means you have to virtualize these servers so that you can be able to use it for different functioning. Making it worse, go to those people who are using bare metal, whereby you can just use one server for one service. So this means that you're going to have how many servers in this case? Maybe 3 servers, one for web servers, other for databases, others for YouTube. All this taking you 8 months to do so. You as a business, you as an individual who wants to spin up a test environment so that you can test your code before pushing it to production environment, you can all tell how hectic the process was. And this calls us to, we have talked about cloud, we have tackled on some of the benefits, but what are these real benefits of cloud computing? First of all is on cost. I've mentioned about cost. What cloud will do, it will help you to have predictable cost. You are going to spend on, you're going to pay on only what you spend, and that's why you call a model pay as you go model. You're only going there, if you're going to spin an instance, in this case, maybe an EC2 instance, I'm going to set up a virtual machine. I'm going to use up an app service. Maybe I'm going to host a static web app on cloud. I'll just pay for what I use in terms of the vCPU, in terms of the network bandwidth, and so on. And then when I decommission this service, I stop paying. When you compare to a traditional way, whereby you say, if you've done your testing, imagine you took around 8 months to set up the server from the point of ordering it to the point of configuring it, then you've just done a single test and then your server becomes idle. You see, then this begs the question of wasting resources. But with cloud computing, with a pay-as-you-go model, you are able to have predictable costs and you only spend on what you are using. We are moving away from the capital expense to our variable expense. We are only paying for what we're using. The issue of scalability, I had mentioned to you, was an application like Jumia, whereby we have high traffic during high seasons. A lot of people visiting these applications. So with cloud computing, we'll be able to scale up. So there are 2 types of scaling when you talk about the cloud computing. We have horizontal scaling and we have the vertical scaling. Vertical scaling, this one entails you improving on the, maybe in terms of the power supplies, in terms of the capability of this single service that you're using. It's just a single service that you're using, but you're moving into a higher version of it, because the higher version will give you the higher performance or operation. And then horizontal scaling is just one, but we are improving the number of the instances that we have. In this case, maybe a good example, you can have a microservice, maybe a microservice applications, whereby the various applications, they're using a single aspect. They're isolated, they're totally isolated. Maybe something that is having my backend is sitting on a different server, in this case, a different maybe app service plan. Your front end is sitting elsewhere, your database is sitting elsewhere. You're able to scale each component individually. You can improve maybe I'm having a lot of traffic coming into my front end. I can have multiple instances of the front end to handle those traffic. We can have maybe our database is being crashed or is being choked by a lot of requests. We can scale up, we can scale out, improving the instances that we have. The issue of reliability. So the cloud will give you high reliable. Normally, most of these cloud providers will give you 99.999% or 11 nines in terms of the reliability. What this means is that they assure that the service will almost be up throughout the year. And in case of failure, you are able to fail over to if it was availability is on, you see, your application was sitting on one data center. If this data center goes down, you are able to be failed over to the next data center. So you are having a highly reliable solution or highly reliable application. You stop suffering, you stop burdening yourself with the question of what happens when Kenya Power decide to do its thing. What happens when maybe I have earthquake at my place, will my data center goes down, and that means the end of my application. So when such things start pulling up in our minds, we start thinking about cloud giving us a reliable environment. The aspect of security. So in terms of security, normally when you consider a traditional way, in a traditional way, we'll just have, maybe we have our WAF, our web application firewall sitting on-prem, and this one was to protect our application, or maybe we have a firewall sitting on our data center, and we channel all traffic towards that firewall. So any traffic that was destined outside our data center, or any traffic destined to our internet, it was to go through our firewall. But that was the traditional way. Nowadays, security has revolutionized. We are no longer protecting things at the network level. We are coming down to data. We have had discussions on data security. You know how essential is information security. And when you talk about information security, data security, what rings in our mind is identity. This begs the question about how we are handling our identity security. I'm having my data sitting, maybe sitting a region, let's say West Europe. My data is sitting in West Europe. I only want people from Kenya to be able to access this data. How can I do that? In a way, you can argue that we can restrict this one through firewall by just having us maybe these source IPs that can reach our data center. But I would love to challenge you, if we think in that way, what if maybe I'm an intruder, I'm an attacker, but I found myself in the right IP range that you want? That means that by virtue of me being in the allowable IP addresses, I'll be able to access my application. I'll be able to access my data that is sitting maybe West Europe. And my intention as a business, it was to only allow specific people, maybe legitimate people, to access this data. So within identity security now comes to play. It has now become the real thing of the talk. Everything is on identity security. And this begs the question of, maybe am I ensuring that people, they can prove to be really who they are? Am I enforcing multi-factor authentication? Am I using something like conditional access to allow people to access this data? Am I using something like identity protection that can be able to detect a risky user, a risky sign-on, and maybe a sign-in, and maybe prompt them for further information for validation? That brings identity security in the picture. And when you talk about identity security, there's no lie. We can all agree, cloud providers, they put a lot of efforts in ensuring that comes with identity security. When you come to AWS, we are talking about IAM. When you come to Azure, we are talking about something like Azure AD. You've heard about Azure AD, you've heard about the various components that it comes with it to ensure that identity security is at its core. I believe there's also the same story when we come to Google, when we come to Alibaba, when we come to all others cloud providers. The other benefit that we get when we adopt this cloud, it is the speed and agility. Speed in terms of, we wanted to spin up our resources. I wanted to ensure that I as Moringa can be able to send invites to my attendees telling them that the meeting will be from 9 to 1, this and this day. I don't want to spend 8 months to do so. I can just do that in a click of a button. So that in terms of the speed. What about agility? Am I able to, what is my reaction? A reaction to change. Something has happened. Am I able to react to that demand? Maybe in this case, a lot of people are coming to this session. Am I able to allow many people into it? That calls for agility. And exactly at the moment, what you're talking about, what we are using is we are consuming a component of cloud. And this component is Zoom. As by using Zoom is a type of a service offered by cloud. Yes. So far, is there any question, any clarification? Those who can monitor the chat, is there anything that anyone needs clarification on?
Yes, we have 2 questions. Okay, Samuel, please go ahead.
Okay, so we have a question here. by Salek Mungai is asking, do you choose between which cloud service you learn between those cloud providers? If so, which one would you recommend?
Okay, for that, allow me to tackle it later. I will come to that slide later. I will handle it later. Thank you for the question. Allow me to tackle it later. Is there any other question? The other question?
So another question from Malcolm Buluku is asking, what is a microservice?
What is a microservice? All right. Yeah. So in a way, okay. Thank you for the question. You're talking about what is a microservice. Let me talk it from an overview perspective, and then that's something that we can go and dig deep into it. Let me take, for instance, which kind of an application that you can divide into the various components. Have maybe our e-commerce site. Try to imagine what kind of the services will need, this e-commerce will need, what kind of the component it will need. This e-commerce, I will need people to come and pay through the e-commerce when they purchase something. They should be able to pay maybe through M-Pesa, they should be able to pay through Visa and also all kind of a thing. So I would want to construct my application or this e-commerce site in that the payment method is totally isolated from the other component of this application. I want it to be isolated from maybe how my front end, it will be part of the back end, but I want it to have an isolated environment. So the payment method will be different. Maybe I'm having a section whereby people will be accessing this particular type of good. I want it to sit on a different part of it to be really isolated from each component. In that, in case of patching, in case of improvement in either of these components, I will be able to handle a component as an individual. I will not be affecting the whole application. I will be able, if I want to do some patching, some improvement, code updates on these particular component, in this case, maybe the payment method, I will just be only affecting these service. So in a way, we have decoupled our major application from a monolithic into the various services. We have broken it down into the various chunks, and these chunks are sitting in isolated environment from the others. A good case can use containers. Containers, we have a cluster nodes, and each node is hosting a different service. So in case of anything, one service will not impact my general performance of the whole application. We can just deal with it in just an isolated environment. Yeah. That is on an overview on how I can picture the microservice concept.
Okay, thank you, Albert, for responding to that. So if I'm getting right, you're just saying that a service is just like a small part of an application that handles a specific task, maybe a feature, but the application may be having several features. Now the microservice is just that one part of the application that is independent.
Yeah, exactly. That one is in an overview. We can directly define microservice in such manner. Thank you for that.
So there is another question here from David Odhiambo, who is saying, I'm currently learning networking. I have plans to specialize in network security. Could cloud network security be an option for me?
Totally, yes, totally. That is a yes. Why are we saying this one? You remember the first one I said, let us try to restructure how people think about cloud. We're just saying that cloud is someone's computer, but in this case, I'm trying to challenge us and say, cloud is, in as much as someone's computer is a data center plus networking, because we should be able for these services to communicate with each other. And you realize when you have a very strong hold in networking, it really plays a very great role when you come to cloud computing, when it comes to containerizations and all those kind of a thing. You really need to have that networking scale for you to be able to troubleshoot even how is your load balancing node be able to route traffic between your various microservices. I'm using container. I'm having a load balance fronting my application, but I'm not able to hit this particular service on this port. So if you try to think it that way, you try to think this one is networking. In terms of network security, your skills that you have in network, they are seamlessly transferred to cloud. You are coming there. Yeah, we still have firewalls in cloud. We are not abolishing cloud. As much as we're talking about identity security, that is fine. But we are still talking about, we still have these network security features in cloud. We have DDoS. Are we able to protect our resources from DDoS attacks? That is distributed denial of service attacks. Are we be able to route on how we are routing our traffic to the internet? I know this one is my application, but as we'll see, we'll have a very short lab session at the end, but we'll see how the aspect of networking is coming in there in terms of improving our security. And at the end of it, it translates to a good security posture. And that is a very admirable skill that you can have. So please go on with that. That's really fine.
Okay, thank you so much. So do you want to take more questions at this point?
If there is a question concerning this slide, that would be better, but we can continue. Okay.
So there are two questions. So the first question, there are actually three questions. So the first one is there any scenario that you can consider using a monolithic microservice and not a decoupled one? The second one is, could you elaborate on serverless cloud computing? And then the last one, aren't there automated security enhancements in cloud?
Okay, all right. So we start with the first one. Maybe will you repeat so that I ensure I address the specific need? Repeat the first question. Okay. We start one by one.
Okay. So is there a scenario that you can consider using a monolithic microservice? I think he meant a monolithic architecture of a microservice. Yeah.
Okay, I can't say that there isn't. There is a case, and this, in a particular case, it must be supported by maybe very, very strong reasons why do you want to maintain this monolithic architecture when you are moving to cloud. There are some of the applications, they work better in the monolithic way. I don't have a specific in mind. Yeah, but the audience, if you have specific, you can share the chat. There is a specific application. There is an application that it is a requirement to stand on monolithic. That will be okay. But in most scenario, I would advise you go with a monolithic architecture, because we will not be using the advantage that clouds give us, because cloud will want to give us, we have scalability. I will want to be able to scale each component of my services differently. So if I'm using a monolithic architecture, then when I come to cloud, you see, it tries to prevent us from leveraging the power of cloud computing. So in a way, that will not be really advisable. And then on the next question.
Okay, so the next question is, could you elaborate on serverless cloud computing?
Okay, all right. Okay, however, that one I will cover in the next slide. But what essentially serverless cloud computing, or maybe serverless services, means, in this way, you are not provisioning a server for you to accomplish your task. And in this case, take an example like Lambda. Lambda, it is only triggered. It is something that will trigger this service to run. A good example in Azure, we talk about Azure Functions. You are not provisioning the server. In most cases, you will see you're provisioning the server, and then you will have your application running in there. But for serverless, there is a server. Let us remember, there is a server, but this server is being managed by your cloud provider. But you're all in charge of the coder there. So your service or operation will only run when there's a trigger, when it's triggered. Maybe a good example, it could be on monitoring. I want to monitor applications, in that when there's a specific, there's a specific, you can say, in terms of the CPU usage of the service, or maybe high traffic. Let's say maybe when there is high traffic, this notification acts as a trigger. It will trigger my Lambda function. And what this Lambda function it will do, maybe it will call our messaging services that we have in cloud. Maybe in Azure, we can call a service bus. it will create a queue, and this queue, it will send the various notifications to those people who have subscribed to this given topic. So you have seen that this Azure function, it only runs when a particular thing is triggered. So it has a trigger. Our case will just write code. We are not going there. We want to provision our resource, putting it in this and this region. No. So that is basically serverless. But in as much as we're calling it serverless, we remember that at the back of it, there's a server, because our code will run on a server, but the server is being managed by our cloud provider. So we're just not provisioning the server, and our service will only run when there's a particular trigger. So essentially that is serverless services.
Okay, thank you so much for answering that. So the last question that you have here, aren't there automated security enhancements in the cloud?
Yeah, of course, there is automated. I believe those who have been in the security ecosystem, you have heard about the same solutions, that is security investigations, remediations, management, something of the sort. You have heard of this, so they are there. These are the security tools that are there. The cloud provider has given you these tools. When there's this, maybe when there's this kind of attack, do this and this. When you sense there's maybe malicious login, by the power of AI, do this and this. But it is for you as an organization, you as an individual to leverage these services. The cloud provider will give you to do. They are there, but it is you who have to consume it. That's why we said in cloud, it is a shared responsibility. Security in cloud is a shared responsibility, whereby the cloud provider will give you tools, and then you as an organization, you will have to consume these tools. You'll make use of these tools. But by default, if you don't enable this tool, and then you'll have a poor security posture. Yeah, so they're there. These automated remediation, they're there. For example, a good case is you have noticed a malicious signing into your device. You have maybe a run book that goes, if this malicious signing in my account, you have to deploy maybe a certain run book to take an action. Yeah, the cloud provider will tell you, okay, there's this. So it can automate, but at what point, what will it automate to? So you are the one who has to define it, because business needs vary. Your need will vary from the other business need. So they're there. The cloud provider will give it to you. So you're the one who have to take leverage of them. All right. Okay, so keep the question coming as I proceed to our next slide. So our next slide, we are going to talk about the cloud computing models. When you're talking about the cloud computing models, you want to picture this into two ways. We want to picture it in the deployment model, and then we'll also picture it on the service model. So when you're talking about deployment model, these are the way in which you deploy the cloud computing will be deployed. A good case, let me start at the top. We're talking about the public cloud. Just as the name suggests, is a public cloud, meaning that the public has access to the resources. It is meant to be used by the public. Suppose you're going to job, you're going to school, you are from your place, you board a public means of transport, maybe a passenger bus. You see, the bus is there. It is meant to be used by the public. So just as the public cloud, a case can have maybe AWS, Google Cloud, Azure. There's a public cloud there. Anyone can just go there with maybe a right subscription to the cloud provider. You can provision your resources. What you take care is the payment, because even for the passenger bus, you'll only pay a fare, but the bus owner is the one who will take charge of the fuel, is the one responsible for the fuel, for the maintenance, for all those roadblocks, to ensure that you have the necessary insurance, all those things. Those become the stress of the owner. So in the same case, in the same version, the public cloud, it becomes the responsibility of the cloud provider to ensure that the infrastructure is out there, people are able to provision the various resources that they need, but you just pay for what you use. You just pay fare. So that one is a public cloud. But for a private cloud, this private cloud, it can be owned by an organization or a single business. This one is just for you. the organization is provision the private cloud for them to use it, just for them to use it, not meant for people to come and rent spaces there or for public use, just the same way as the private car. The private car, it is meant for you want some level of privacy. And also these cloud providers, they provide this private cloud. When you come to Azure, there is this, for example, the US government. The US government is just a private cloud. When you come to Germany, there's also the Germany cloud under Azure. That is not meant for the public. It's just meant for the specific reason. For a case of US government cloud, it will just be the US government and just the only one who are able to use this cloud. But there are a lot of stresses that comes with it. You having a private cloud, meaning that you're the one, just as the private car will be, you're the one who has to fuel it, you're the one who has to take it for maintenance, you're the one who do the services there. You entirely responsible for that cloud. And there's a bit of confusion I've seen with a lot of people. They believe that if they have a virtualized environment on their premises, that is a private cloud. No, that is not a private cloud. You can have a virtualized environment whereby you have the various virtual machines, but if that environment is not able to exhibit characteristics of cloud computing, the case of scalability, the case of reliability, the case of predictable cost, that is not cloud. That is just a virtualized environment you have at your place and you're just using it. So that will not be a private cloud. The private cloud will have the same capability the public cloud will have. Only that in the private cloud, you are the one it is not meant for the public use. You just the specific person who is using this cloud. And then there comes hybrid cloud. As the name suggests, this is a combination of the two, the combination of the private and the public cloud. At a point, you may feel that you need some kind of privacy. You are using some component of private cloud. At a point, you will also have some resources provision at the public cloud. A good case is Uber or Bolt. So in this case, Uber, you can just, the way the Uber operates, can just be meant for the privacy. You see, you taking the Uber, you alone, you want some kind of privacy, so you will achieve that privacy. But at the same time, this Uber is meant for the public use. Anyone can schedule for this Uber drive, or maybe book this Uber. So you have is a combo. We have some flavor of private and also some flavor of public cloud. And another thing that I've not captured in this slide is the multi-cloud. So indeed, the multi-cloud. Sorry, there is a question. All right. So in the multi-cloud, now we are using the various public clouds. Maybe I'm having my main services running on Azure. Maybe perhaps I need other services running on AWS. Maybe my disaster recovery running on AWS. I need to use some kind of my database that is running on Oracle. So you see, I'm using a combination of all these public clouds. So when I'm using all of that, that becomes a multi-cloud. A good case in mind where maybe I'm using a multi-cloud, maybe I want to avoid vendor locking. I don't want to lock myself into maybe this specific cloud provider. I want to have you'll be free. You can move from any of these cloud providers, and that calls for the public cloud. And then on the service models, we have 3 specific cloud computing service models. The first one is infrastructure as a service. We have platform as a service. And then the last one we have here, software as a service. And for these 3, I'm going to tackle in the next slides. Okay, so before we can tackle on the various service model, in this slide, we have analogies that it can make us try to understand when we're talking about these various cloud service models, which are these. So a good case, we're using pizza as a service. The first one is on traditional on-prem. This one is on-prem, whereby in the relation of this pizza as a service is like everything is made at home. You see the blue one, this under blue is what you manage. So you have to make cheese from home, you have to make your toppings, you have to make your tomato sauce, pizza dough, you have to make fire. oven, electrical, gas, soda, then dining table. Like you are entirely in charge of everything. That one is on a traditional or on-prem. That is a good correlation of pizza made at home. Another one is when you take and bake. So in this case, you don't want to go through the stress of making cheese. You don't want to go through the stress of making toppings. You don't have to go through a stress of making the tomato sauce. You don't want to go through a stress of making pizza dough. So you want to go and buy the cheese, toppings, tomato sauce, and leave that stress to the manufacturing company. So that is a good illustration of infrastructure as a service. A good portion of it is handled by the provider. It is handled by someone else. For your case, you put the stress of fire, the stress of oven, the stress of electric gas, the stress of soda, and dining on. So that is the stress that you want to take. You don't want to put yourself under the other stress. The other one is a platform as a service. For platform as a service, this one, and here, there are a number of the things that's been taken away. A number of the stress has been taken away. These are good examples like pizza delivered. You just go there and then you say, okay, Tuesday there's an offer of pizza. Let me make an order. So that one is delivered at your place. The only stress that you have to go through is buying soda and ensure that you're having a dining table. But all the other stress like making cheese, toppings, tomato sauce, pizza dough, fire, oven, electric gas, that has been taken by the one who prepare that pizza. And a good, the final service model is software as a service. This one is like you're going to dine out. So yeah, it is this on 14th of February, you want to go out, you just there, you maybe at Pizza Inn or maybe a favorite place of pizza, and then you just order it, order everything. You totally go through no stress. Everything has been catered for. So that one is a software service. In correlation to that, so when you're talking about these service models or the cloud computing models, and this is what it pictures. The first one, it was on the classic or the traditional one. Traditional one, so you have to take care of the networking, you have to take care of the storage, you have to take care of the servers, you have to come and virtualize the environment, you have to ensure that the right operating system is in your you have installed the right operating system, be it maybe it's a Linux or a Windows. You have to ensure that the middleware they are there. You have to ensure that the right time is running in your service. You have also to ensure the security of your data and application. So basically, on-prem correlates to our example there above, whereby you are to make everything at home, pizza made at home. You have to every details. You are going through all the stress. But in infrastructure as a service, in this infrastructure as a service, there is the cloud provider, which we'll tackle them later. So in this case, I've talked about them, the AWS, the Azure, the Google Cloud, Oracle, just name it. So they're the one who are taking care of the networking. They're the one behind the scene that are taking care of the storage. They're the one who are taking care of the servers. They're the one who decide the right technology to virtualize the environment. Then you as an individual, you as the business, you're the one who will be taking care of the OS patching. In this case, we're talking about guest OS patching. We are talking about middleware. We're the one who will be taking care of the runtime. Suppose you're hosting maybe a Node.js application, you have to ensure that maybe the right runtime, like maybe Node 16 has been used. You're the one who is taking care of the data. You're the one who's taking care of the application. That one is infrastructure as a service. So you have bought all the pizza dough and you're just making the other part of it. And then for platform as a service, for just a second, let me take you back. For infrastructure as a service, an example there, it could be an Elastic EC2 instance. You can also have a virtual machine, which is a VM. You can also have Google Compute Service. Those are the good examples of infrastructure as a service, whereby the underlying infrastructure has been taken care of by the service provider. And then there's a portion of the stress that you're going to take for you to have a complete solution. Then the other one is the platform as a service. For the platform as a service, so in this case, a big chunk of the stress has been taken by the service provider. You're just there for your data and application. And this is what we are going to do in our practical session. We are going to see, we are not going to take care of these other stress. We are leaving it to the service provider. Our stress is only on the data and the application. A good examples of application as a service for those in AWS, you have Elastic Beanstalk. For those in Azure, you have web app or an app service. And then the last service model is the software as a service. For the software as a service, you literally don't want any stress. For this case, you are leaving it to a service provider. Service provider will take care of everything. A good example is Zoom. We are here in Zoom. What you have undergone for you to be here is just clicking that link and signing in. You don't want to stress yourself on how the networking part of it sits. You don't want to stress yourself on the storage aspect of it, on the server aspect of it, on the virtualization, on the operating system, or all the other stress. That one you leave it to the cloud provider. And for you, you were just there ready to consume it. Another good example, we have Gmail. Another good example, we have Microsoft 365 platform. I know a couple of you are using that one. Your Outlook, your Word, your PowerPoint, you just name it. So those are examples of software as a service. So far, is there any question concerning the difference between the deployment model and the service models? For the deployment models, we have talked about the hybrid, the private, and the public. While for the service model, this is where we're talking about infrastructure as a service, platform as a service, and software as a service. If there's no question, okay. And then
so there is
another question.
There is one question.
Okay.
So somebody, Ben Kivuva, asked, can you explain a bit what hybrid cloud is and use cases?
Okay.
Was this before or after? Not sure if it was before you tackled it.
Okay, yeah, that is fine. When you're talking about hybrid and the use cases. So in hybrid, you have said you're using some part of it you're using on the private cloud and some part of it you're using on the public cloud. So on the private cloud, you will want to maintain a private cloud, maybe because we are dealing with very sensitive data, or you're dealing with something with needs very low latency. A good example could be, let me just take an institution. Let us take about the US government in this case, something that you can all try to relate to. There's some aspect of which we don't need any public access to it. They're very critical. These are very sensitive information, very sensitive application, very sensitive data that we don't want to push it on the cloud. Suppose personal information, personal identification informations, like your card numbers, like maybe your own personal data sets. We don't want public access to that. So we decided that this kind of information, we are abided by the law that this kind of information cannot go to public cloud, cannot go to whereby it's sitting on the data center whereby someone else can come and put other things there. So for this specific kind of information, we are maintaining it on a private cloud. However, for my business, there are other applications that I need to run. The other application, maybe a good example, I'm operating e-commerce, whereby these people are going, I want the public, there are people going there to shop or kind of a thing. For such a specific thing, I can say, okay, for this, let me host it on my public cloud. I can host it, maybe whichever my provider is, I can decide and host it there. So if you look at this business or this organization, it has a combination of both. There's some aspect of the private cloud is being used here, and there's some aspect of the public cloud is being used there. So in such a model, since there are businesses who exist in such a model, we call them, they exist in a hybrid cloud. They are using both hybrid cloud. So that is a scenario whereby a hybrid cloud is being in use. I don't know if that answers your questions. That is okay.
There's that, yes, he has responded that he has been answered. Yeah. Okay, thank you.
All right,
you can go ahead.
All right, thank you so much. And then we had the cloud providers, whereby we talked about, we have a lot of cloud providers. So these are the one who owns these data centers. We talked about something like AWS. We talked about Azure being the Azure, which is the Microsoft Cloud. We talked about Google Cloud. We talked about Alibaba, and there are so many nowadays cloud provider. In the space, you also have Cisco offering cloud, but something still growing is a journey. Most of the organizations that come in, they have seen the need of cloud, and they're now offering cloud. And later on, you'll see them maybe pronouncing them as a public cloud whereby people can use. But essentially, they're just private cloud. Maybe for them to enjoy this benefit of cloud, and maybe because of the governance, the law that is there, which they prevent them, they cannot make use of the public cloud, so they go in and make their own cloud. So in terms of the cloud provider, there are many. For you, in terms of maybe which cloud provider you can take and which one you can learn, there are a lot of things that comes into play before you say, I want to take this. I'll talk about two kind of individuals in this case. One, let me start with a student. For you as a student, you may be learning and certifying. There's a financial aspect of it because you have to pay for those certifications and also for those knowledge. As a student, I will recommend you just learn any cloud that you have resources on. For example, there's a challenge that is going there. People are being given vouchers in AWS Cloud Practitioner. As a student, you just grab it. Have these resources just been made for you. You just utilize of these resources, you just learn. Why? At the end of the day, when you go to a driving school, you don't go there and just learn how to drive Toyota. I believe you go there, you use Toyota during your driving lessons. Out there, someone give you a Benz, you will comfortably take some few minutes and be able to drive this Benz. So when you go to a driving school, you don't learn how to drive a specific kind of a car. Rather, you learn how to drive the car. It doesn't matter which model of the car you're using to drive. What matters is what was there, the resource that was there that helped you to learn. Just the same way as cloud. It doesn't matter if you start out in AWS. It doesn't matter if you start out in Azure. The concept is the same. Why? As I've said, cloud computing is the provision of these IT resources over the internet with a pay-as-you-go model. So if you're able to understand that concept, I'm just using an IT services, but on a pay-as-you-go model. These various cloud providers will have various names. Amazon, AWS will call them EC2 instance. When you come to Azure, Azure will call them virtual machine. When you come to Google, Google will call them Google Compute Engine. So essentially, they're just the same thing because they're just virtual machine. They're just servers for you to run your work. So it doesn't matter which cloud you start out in, just use the resource that you have. If you have resources in AWS, exactly, learn it. If you have resources in Google Cloud, just learn it. You don't limit yourself by saying you want to just learn this specific cloud. The other thing is when you're in the industry, you're already in the industry, your organization is using maybe Google Cloud in hosting your applications and in serving their customers. I tend to believe that you being part of that organization, you'll have to learn Google. You'll not have to say, I want to learn AWS and you're not practicing it because at the end of the day, it's not making any benefit to the company. So for someone who is there in an organization, what will maybe influence what cloud you learn is the organization leader. You'll be there, you want to bring value to that company, you will learn the cloud that the company is using. I'm dead sure if you're in this company that are using Google to host the application and to serve their customer, when you migrate, you come to maybe a company that is using AWS, it won't take you too much time for you to understand this concept because it will be just a matter of 1 week to brush up to see how these AWS, they're calling their service. Because in Google, you're calling this way and you're hosting your cloud, you're hosting your services in this particular manner. So you just want to know the correspondent maybe services and how they go about it. And it should take you less time. So in this case, you have seen there are a number of things that can influence what kind of cloud you'll start. So for that one who asked maybe which cloud I can recommend, I will recommend go the one that you have resources. If you're an organization, learn the cloud that the organization is using for you to be of value in that particular organization. And that begs us to this question, what is in for you when you learn this cloud? So cloud being among the training technology, it will be a good way to secure the future because organizations will now start being pushed to move towards cloud. Organizations are now we see most of these vendors, they're retiring support for a number of their on-premises services. For example, a good case for those who are running Windows servers, we are running maybe Exchange Server 20-something. A good case is Windows Server 2012. People who are running Windows Server 2012, you see it is becoming end of life in this September or August, either of the two. What this means is that Microsoft, in this case, they will stop offering support. You'll never have a case bringing up the concerns Windows in this particular type of Windows. So these vendors, they're now trying to retire support. They're now trying to retire maybe their support to this particular obsolete technologies or obsolete services that you're using. What this means as an organization is you have to move with the trend. And in this case, people now start acquiring maybe something like Exchange Online. So they're going to cloud. That's the cloud model. You're moving to Exchange Online. That is a PaaS service. So a good way you're learning it at the moment, you are securing in the future, because just a matter of time, and then we'll see people being pushed to move there, because the kind of the technology that the vendors will be offering, they're the technologies which are using cloud. Another way is a good way to differentiate yourself. We are DevOps, we are learning development, but we want to host our applications we want to build our cloud native applications, the cloud that can use application that can use cloud services. I want to build my application that it can scale up depending on the traffic that it receives. I want to build my application that when there's a disaster, my application is always up. So you see, other than me just saying I'm going to host my application on Heroku, or maybe that is a traditional way, I don't have to go through those stress of maybe putting npm start, npm installs for me to host my application. Why can't I just leave that one for automation to be done by the cloud provider? And then for me, I just be responsible for my code and my data, and then make it run on a PaaS service. So it is a differentiator in a way. You start building applications that they use cloud native application, an application that when you pull this code to cloud, it has met the minimum security requirement, it has met the operational baseline, and it is up to run in a modern world. So, and then there's very great careers also when you learn this cloud, become the DevOps engineer, the one that the community are doing, really very great. You want to become a solutions architect, whereby you listen to the kind of the stress that the business are having, and then tell them, I see you have a very sweet stress, allow me to make it good for you. You maybe provide them for a solution and to their needs, and ensure that the only stress that the business are going through is how to meet their goal. Let them not go through stress of who will manage my server, who will manage my data center. That is really a great thing if you ask me. And then if you're able to have all these, I believe that you'll be happy. Yeah. And I believe that what creates happiness. You try to be on the move with the current trend. Nowadays, AI is taking the lead. AI will use these cloud computing services because there is very massive AI tools on cloud. AI will consume a lot of the resources, and these resources can only be provided in a better way with cloud services. You will not tell me that you're going to train your model on a local machine. Machine will crash, machine will not have the modern capability to do so. So you leveraging cloud and see how this cloud is intersecting with whatever you are good in. So cloud will become, as you're learning DevOps, there are various tools that you use as a DevOps engineer. And one of the tools that this will come in, a cloud can be one of the tools for you to be a good DevOps engineer. Maybe before we go to our lab environment, are there any questions before we discuss this architecture and try to get our hands dirty? Any question?
Sorry. So there is some questions here. So we have two questions. So the first one is from Elvis. Could you be aware of what, you can hear me?
Yeah, sure, I can hear you.
Oh, okay. So could you be aware of what requirements or standards that an entity should have before becoming a cloud service provider?
You want to become a cloud service provider. And that basically means you want to build your data center. You want to offer those services that the public can rent. can rent. Of course, there are standards whereby these technology companies they have to meet before they could allow you to make it free there for the public to use your cloud services, because you are dealing with data, and as we are talking at this current time, that is something critical. So your environment should be trusted. Your environment should ensure that these cloud providers, they go through audits. So as a cloud provider, there will be just audit that will go. You'll have to convince the panel that if you entrust people can entrust you with their data. If they hold their data there, their data will not be breached. Their data will not get lost because of a disaster. So there are specific, I can say there are specific baseline, or there's specific standards that you have to meet before you become a cloud provider. But that will be a stress, that will be a journey for you to become a cloud provider. Why? You'll have to have these data centers at various locations. You'll have to ensure there's high availability. I believe in such a case, if at all you want to come into play with compete with those old vendors like Google, Microsoft Azure, Oracle, it won't be a nice fight for you to take. It won't be a good way you say that we want to be a cloud provider. Rather, we can say, let us consume that has been given, and let me focus on providing the best to my audience. That can be a good play. But back to the question, exactly, there are various standards, there are various baseline for these cloud provider meet before they start providing these services to the public. Thank you.
Okay, thank you for responding to that. So there is another question here. Are there enough entry-level cloud computing DevOps jobs? I once heard there is a steep barrier to entry, and the easiest way is to transition from another position. Let's say system administration, so as to boost you on the years of experience.
What I can say, maybe for that, let me start with the last part of the statement that you have said, transitioning from the system administrator or something of the sort. That is, before cloud, we had system admins in place, right? Because we were supposed to take care of our data centers, to take care of the servers, patching, and whatsoever. So this one becomes easy for that specific person that will be in an organization whereby he has been the system admin, but because the company or the organization is adopting cloud, he sees a good venture whereby he moves into as a DevOps engineer. That can be a venture for him, but it doesn't mean that maybe there's no entry levels for you. You, in that way, you don't have to go through that part, becoming a system admin before going to cloud. No, that will not be a right way. We will be lying to ourselves if we agree to that. Why? The issue is just differentiating yourself from the large mass. Are we learning this DevOps engineering in the right way? Are we getting the necessary tools in place? Are we getting the necessary knowledge in place? Just to avoid you having those knowledge gaps. Even if you're learning cloud, I don't expect you just to be learning cloud computing alone. I want to expect you will be just a solutions architect will be just as good as the way he has grasped knowledge through his journey. I want you to understand as basic as IP addressing for a solutions architect. For you, understand the network first for those who are coming into cloud computing, because that will really matter a lot. I believe the same case is in the DevOps side. There is a very huge kind of knowledge that you have to immerse yourself before you be a DevOps engineer, not just by certifying in one kind of cloud certificate, or maybe just one certificate, or maybe grasping one knowledge. It will make you a differentiator, not really. The issue is that just like any other course, there's a bit of barrier you entering into the market, and it requires you to have a couple of skill, other than you just having your technical skill. It requires also you to do a good marketing for yourself. You take yourself as a product. You as a product, just as a product enters into the market. It can be a very, very unique product. Can all agree that. But what does it take for it to enter the market? It has to come, various aspects of it comes in. The way you do promotion of this product, the way you package it, the more you profile it. So just the same way as we are, let's take ourselves as products. Take yourself, if you want that entry job, you are the product. there are a number of products out there that have been published. So how are you different from the other products? You have the right skill set with you, the right skills. Yeah. So when you talk about the scalability and employability, there are a lot of things that come in play, not just the concept, but yeah, it is a lot of subject that we need to discuss before we can rule out something. Yeah, all the way from marketing, all the way from your skills, all the way to on how you differentiate yourself. That is how the recruiter will say it. And yeah, and back to the question, there is no barrier. It's how you're breaking that entry to the market. There's no need for you, first of all, to meander along before you come into the field that you want to. As long as you've identified the field, ensure that you have the right tool set with you, the right knowledge, and you having the right mentors. I will just maneuver through. That is what I can say. Thank you.
Okay, thank you so much for responding to that. So the next question is, for one to go to DevOps, do I have to be good at programming? Maybe I can respond to that. So,
yeah, sure.
So you need as a DevOps engineer, one of the things that you will need by the end, maybe after, for you to be a fully fledged DevOps engineer, is for you to also have some scripting skills. But when you're starting, it's not a requirement that you are good at programming, because as Albert has shared, so DevOps has a lot of things that you're going to learn. And maybe when you're starting, you'll not know about the cloud, or you'll not know about programming. There is something you'll know, and you have to start with one thing. And then from there, you can move into another thing. So you don't have to be good in programming for you to start DevOps. But it will be advantageous if you have some programming skills, or you know how software works. That will be an advantage for you. But even if you're coming from any other, let's say you are a data scientist, you've already interacted with the programming language. Let's say you only interacted with the cloud. Let's say you just went direct into cloud, maybe cloud development, or maybe you're a cloud architect, or you're a network engineer. So all these things are part of DevOps. So they will make it easier for you to learn. So there is no specific requirement, I would say, so long as you have interacted, you know, some basics of computers and how software works, you will be good to go. But now it will depend. So in the future, as you go on, depending on how you want to specialize in your DevOps, now you will require different things. To be good in different things, for you to maybe do different kinds of jobs.
Thank you for that response. Is there any other questions before we?
So
is there a question?
So the last question. Yeah. So there is one more question. So considering that we are learning the cloud, for a person like me working as a backend developer, will it be considered deploying your application using Docker containers and Kubernetes in the cloud? So I think I can respond to that as well. Or
sure. Go on, please.
Yeah. So actually that is one of the ways that is advisable. So when you're working with containers, you're working with Kubernetes, you're scaling, you're obeying everything that you're talking about here about cloud computing, which will allow you to scale. You can scale easily. You can have maybe different features on your application containerized. They're running independently. So, and they are scalable, because when you run in containers and you run in maybe a system like Kubernetes, you're able to manage and benefit from the goodies of the cloud that are provided for you. Like, for example, most of the things will be managed for you. So that is very advisable. I hope I've responded to you, Peter. So there is no other question.
Okay, so it's time to get our hands dirty. But before we get our hands dirty, let's just see what is going to dirtify our hands. So this one is just a simple one. Maybe there's some aspect that has not been considered due to a number of things, but we want to see how can we have an application that it composed of the tools that we have here in this architectural diagram. We try to host. It will be just a quick one, and just as the aim is to get you started with application hosting in a cloud. And this specific allow me just to go down into Azure. So this is when we are in the driving school, and this driving school, I just have Azure available, and we'd love you to come along with Azure. So this one is an application. Suppose you have a business out there, you want to roll out your, let me just use the e-commerce application, whereby we'll need to have a MongoDB there, MongoDB for hosting your catalog and all those things that you display to the user. We also need your application to, you don't want to put yourself under stress of doing the patching, OS patching. You just want to deal with the data and the application that you have. So that calls for you to use a PaaS service. And in this case, we are using a PaaS service that is called App Service. So in Azure App Service is a PaaS service that will enable you to host your applications. You can have the web applications, you can have the mobile applications, and so on. Also, in this case, you have your customers are distributed all over the world. You have other customers that are sitting in Kenya, others in Europe, others in all places that you love to name. So how will they have maybe quick access to this information? I don't want, if someone is in the USA and my database, I'm hosting it maybe in South Africa North, I don't want someone from US to all the traffic to come from US to South Africa, then back. You see the latency that is being introduced there. That is a very large latency. So I want to reduce this latency. I want someone to access the application by just click here, click there. So I'm coming in with an aspect of Azure CDN, Azure Content Delivery Network. What the Azure Content Delivery Network does, this one will do caching. It will cache our content. So at first, the person will go up to the database to get the information, but during the second time when they want to access this information, already there's a cached content there. So they'll very quickly access their data. The aspect of security, we're bringing some small flavor here and there. We have the aspect of key vaults. So the key vaults, these one are used to hold your application secrets, application password. Suppose your application wants to use as blob storage. Why is this application want to use a blob storage? Because the way you have configured, the way you have coded your application is that your application is going to survey, is going to get these services from maybe a certain website. It wants to download that, and these services are being stored on the blob storage. But you also want aspect of your application to access this blob storage. So it means that you have to give it the right identity. So that's why maybe you can have an application that has a blob storage. It is using a storage account there. So your secret, your keys, the way you have configured your authentication on the storage account, that one will store on the key vaults. If maybe there's some keys, and then it will use it to authenticate to come and take these, maybe this list and display it on the site that way. And then since you're having an application, and I believe we are all interacted with the domain name. So in this case, we want to use Azure as our domain hosting platform, and that begs us to go for Azure DNS. The Azure DNS is a service that will help you to host your domain. When you want to add the various records, you want maybe an A record, R record, C records, all those records, you can do it. You want all these things to be done on Azure. So it won't be a good idea, perhaps maybe if you have another reason, but it won't be a good idea to use maybe Cloudflare or the cPanel for your domain services. I can say, let me all have everything under one plan that I can to increase visibility and the management. So in this case, idea comes in our mind, you're going with the Azure DNS. And then you saw when we were talking about yCloud, we talked about full visibility in your operations. So probably I will want to enable logs for my application to tell me at what point is it is the peak, at what point is my application being accessed very frequently, at what point are my infrastructure being choked by the requests by the people. So we want to identify something like what is my ramp up ramp up hours? When is my application start being used? When does it reach my peak? When will it have ramped down? When people are starting to log out of this application? When is the low peak season? So you will want to have visibilities over these various metrics that can help you in making informed decision. And that one, in this case, we're using Azure Monitor. So Azure Monitor, in this case, an Azure Monitor, helps you in monitoring of your Azure environment, and it has various capabilities, it has various connections. You can, and the main type of the logs, the main type of the data that will come to this Azure Monitor, they're the log and the metrics. And over these logs and the metrics, you can then get insights. And since this one is an application, a good case to have an application insight. So we configure an application insight for you to have visibility over operation of your application. But that one will use a log analytics, because down behind the scene, the Azure Monitor, so as many services, they will need a place whereby the logs are being stored before they're being pulled from there. And that one is the Azure Monitor. And then a resource group is just a container whereby your resources will be stored. So what we'll do, we have a new resource group having all these our resources. And at the end of this demo, I'm going to destroy or clean up our resources by just deleting a resource group. When I delete a resource group, it will delete the resources in them. So I will welcome questions. Just allow me to go to the portal. I will show the portal. We try to do a number of the things. Then as we wait for it to deploy, as to provision the underlying infrastructure, we'll come back to this diagram and we'll have to have a chat over it. Yes, I know a majority of you interact with the various cloud. Perhaps you are hosting, you are normally using AWS. A good number of developers I know, they use AWS. Others, they use Google. Every people have their various interests, their various platforms that they are conversant with. But in this case, as I've said, since this one is a driving school, let us drive in Azure, and then this one can easily be replicated with those services you are good at. It could be a nice thing also to see how this sits in Azure. So with that, allow me to share my screen. Okay, I don't believe if you are reliable. Okay, maybe Kidima, could you confirm which kind of screen are you seeing at the moment?
We are seeing the lab environment slide.
Then lab environment, so I allow to share again.
Yeah.
Okay.
Okay.
Allow me to use. Okay, you're able to see, I'm in the Azure portal.
Yes.
Let me know if that is up. Okay, so if that is fine with us, in the next 5 minutes, let us get our answer that in this portal, and then we'll go back to our slide. We have a bit of discussion. We alternate the next 30 to 40 minutes before we call it a session. So as I mentioned to you, in Azure, all the resources are contained in a resource group. So you'll have to create a resource group whereby your resources will be stored. And to do that, you can start from the top there. You just search resource group. Okay. Well, okay, for this one, let me create a new one for these demo purposes. We click on create. So this one, I have to define my subscription. This is a subscription that I'm using, the Visual Studio Enterprise subscription. And then this one is giving a name using the base convention. I can say this RG for resource group. I call it Moringa, Nairobi, dev community. And then this one is using for test. You can name it that way. And then on the country, let me go. Normally people in Africa, they normally hold their resources in Europe because of the low latency and the low price. And then let me also be the one of those people. I'm going with the North Europe. And then on tags, you can configure tags. We say the environment. And then you can say this one is a test environment. So the purpose of configuring tags, this one can be very essential when you do to scripting automation. You can write a script that maybe it will do something to all the resources that have the tag environment test. Yeah, that is really good for automation purposes, and also for you to view billing for billing purposes. You can narrow down to your tags to see which kind of resources they're the one which are occupying a lot of, they're the one which are consuming a lot of resources. So in this case, we'll do create. It will take a couple of seconds, and then our RG it is here. You can see our resource group. So everything that we're going to do as for now, they're going to sit under this resource group. And as you saw from the diagram, we are going to do we're going to use our app service. As I said, an app service is a platform as a service, and this one, it allows us to host our applications. It will allow us to host our websites, just name them. So in this case, I have a sample code in my GitHub, and that is what you're going to use for the purpose of time. But for your case, you can use any. And in this case, let me just deploy just a simple web app. And this is a simple web app is going to use, it is a Node.js application. So you can see from this one, you can just use web app database when you search. In this case, what we want to achieve is that, yeah, we can, a good way it will be, we can start by creating our database first. And under this database, we get now then we configure our backend, because our backend will have to point to the database, if that is the architecture, how it was. So in this case, a good case, you could create database start, then your backend, then deploy your front end. But in this case, I want to do it, all of it at the same time, just to save on the time that we have in this session. So I can go with the web app plus databases. Yes, just forgive my network. And then from here, we have to define the various things. The first one, we'll have to define our resource group. We have this resource group at Moringa. We've created always lab North Europe, depending on the required cloud data center or the region of your organization. You can place it there, but for this case, our validated data center here is North Europe. That's why we are using. For application, I want to give it a name. For the purpose, you can say Moringa, and then it cannot have something like hyphen, because a URL will be generated with .azurewebsite.net. Unless you have your domain, that's when you can create a custom domain. You call it the way you want, but in this case, we call Moringa Nairobi. That is fine for this purpose. And you have said you're going to deploy a Node.js. So in this, our run stack, it will be, we are using a Node 16 rather than Node 18. Node 18 is the latest one. And still, it has some development issues because it is under its roadmap. The compatibility issues, your code may bring a number of errors. So in this case, let us use the existing, the one that has been in the play for a long time, Node 16 runtime. And then for this one, we are going to use a MongoDB, but in Azure, we don't have a native MongoDB. For us to be able to use a MongoDB, we'll deploy a Cosmos DB with a MongoDB API. So the Cosmos DB is an relational database in Azure, but it supports a variety of APIs. So in this case, when we deploy a Cosmos DB with a MongoDB API, it will deploy a MongoDB database, which is, and the background of it is there. It will be the Azure DB. So these are the various DB that you can deploy that one. And the database name, this one has been given by default, an account has been created. And then this one is, it has been auto-generated. In this case, I would love to have some credentials to take note of some of these things, because we'll go to the code and see how the code is. At the code, we have an environment dynamic variables that it will point to the name of the database. So to be in a good side, let me just take that note of that. You can use a notepad. We take note of our database name. I don't know if you're able to see my notepad, but I'm taking note of the name of my database, because I will require it to use the way the code is configured. So I've taken note of my database name, and this one, we don't want to configure a lot of resources. I don't know which cache for Redis, and I'm going to use hosting plan. What this means is that Azure Azure, an app service at the back of it, we have, it runs on an app service, service plan. What we talk about an app service plan is more like the infrastructure whereby your various app services can sit. I can have maybe, as we'll go back, I'll show you on that architecture. I can just have just one app service plan, and then you have a number of them, a number of the websites sitting on top of it. In a good case, you can have a number of the app services plan whereby the various web services it sits. An app service plan, what it means, it is underlying resources. These are in terms of the CPU, the Docker, and everything. That is what an app service plan means. And in this case, I'm just using a standard. And you'll see with the aspect of auto scaling, you can move from the various, normally there are the various tiers of this app service plan. And for that, you can move to them. You can upscale depending on the metrics that you have collected. Here, we also put our environment and test. A good way you could use Azure policy. An Azure policy, it will force down all the resources created under this resource group to inherit that tags. But something to take note in Azure, resource group cannot be inherited, and tags cannot be inherited. The only way you can enforce tags down the stream is by using of policies. And when you talk about the various, let me click this one to create as I try to enlighten you something about Azure in terms of that hierarchy. Azure, it has the various hierarchy. At the top of it, we have the management group. From the management group, we have the subscription, and then we have the resource group, and then we have the resource. The top there, you can have the various management group depending on maybe the way organization is sitting, maybe the various branches. The Kenyan branch can have its own management group because it will be ruled by a policy in Kenya and policy in a different country will matter. So you can have various management group for that. Then at the subscription, this is your billing. You can have the very billing entities. This is where the billing will happen. So you can have the various billing entities at the subscription. Then the resource group, it's the one that contains your resources. Then resource is a specific resource that you want to deploy. So this one is deploying. As it deploys, we give it like 10 minutes because it's going to deploy a number of things. We'll check in. It is going to deploy our database. It's going to deploy our app service. Then after it has deployed, we'll come back and add the code. And that we'll do through GitHub to achieve. We have a CI/CD pipeline. We'll just add a GitHub, and in this case, we're going to use GitHub Action. So we'll come back here in the next 10 minutes just to see how everything is and to have a chat on that. In the meantime, is there any question before I share back the slide? We have a chat on that. So far, is there any question?
So there is one question. So
Okay.
somebody is asking, maybe for the sake of those who might not get it, why should you delete resources after using them?
Okay, so in this case, we are just deploying this one for our demo. So you remember when I said you just pay as you go, you only pay for what you want to use. For us, we just want to use this one to demonstrate. Then after that, I don't want to continue paying. Unlike in traditional way whereby I could have provisioned a server on my server room and then leave it there. So here, after we are through with it, I just decommission or I clean up those resources just to avoid being billed because I no longer need those resources. That's the need of you destroying or cleaning up the resources.
Okay, thank you. Thank you so much for that. So there is another one from Diana. She's asking, for an individual who is new to this field, what can I begin with and how can it be a source of income to me?
Okay, so just like any other technology, I believe we don't love technology, we just love what technology does for us. So in this case, you will have to learn the technology, and the only way you'll benefit is you using the technology to see the existing problem and then use this technology to solve the existing problem. That is how, at that point, it will be your source of income. A good example in this case, you are hosting your platform in various the way you host your applications. I know there are normally various ways in which you can host your applications, but in this case you have realized, okay, when I try to host it on cloud, I will achieve these specific benefits. I will have these insights which it will help me make some decisions. And then you see the existing resources, see, oh my goodness, we have maybe our iTax system whereby people go there to pay their taxes. The system is always flooded, low latency, I believe, as we approach towards the end because of high peak. So you see, okay, my existing problem is that the current application that we have, it cannot scale up, or maybe the way it has been architected, there are a number of the loopholes here and there. So that becomes the problem. And then you see, okay, I learned something somewhere. So how can that be used to solve this existing problem? So as long as you identify the problem and how the technology can solve, that is the only point that it will become a point of income to you. Then from there, you start opening up discussion that's a channel towards financial gains, something of the sort. You bring them on board, you start discussing on the architecture of their diagrams, of their applications, on how they have hosted it, and try to provide them the value proposition of when, if they can come maybe to cloud. And since you took some time to study this application hosting, it will be very comfortable for you to host the application. And I believe for that, it will be a source of income. To start with, every cloud, there are just like any technology, there are various steps. There is that fundamental stage, there is that associate stage, and there is that the professional stage. Whichever cloud that will be, going back to the factor that will affect the cloud that we learn, that we have discussed, identify that cloud, look at the fundamental. I will likely to advise people, start from the very beginning. Why? We don't want to have this knowledge gap. I want to understand everything bit by bit. You start from this fundamental. After you have learned the fundamental, there is always a proposed roadmap for you. Look for the roadmap. You're in development side, look for the development side of it. You're in infrastructure side, look for the infrastructure side of it. You're in the network side, look for the network side of it. So after you have identified that track in that way, then upskill towards that roadmap. At the end of the day, you'll be very conversant and very familiar with these various services. So that is the point that where you can start. And I believe about both sides of the equation, how you can start and how this can become an income to you.
Okay, thank you so much for responding to that. Diana, I hope you've been answered. So,
is there any other question? Or I share that slide. We have a chat as this one is deploying.
So there is a question here from Neville.
Okay.
So it's asking for a blockchain developer trying to achieve decentralization. Isn't running my application in such a system defeating the purpose, and how can I circumnavigate it?
Okay, you want as the blockchain what developer or something of that sort?
You're trying to achieve decentralization.
All right, decentralization can be, you remember when I mentioned from the top of it, we say there are various hierarchy. We start from the management group, at the subscription level, at the resource group level, and at the resource level. All these, it is independent. It depends majorly with your business need or your need that you want to achieve. I want to achieve isolation, which is normally the decentralization. So I want to achieve decentralization, but at what level of decentralization I want to achieve? If I come here and I start creating a different management group, right from that start of having two different management groups, I cannot view the resources, or when I'm given someone permission permission under under this one management group, he or she will not be able to come to the other, or also to the application, because these applications are going to use to manage the identity and service principles. Just the same way from the top there, you can separate these issues as separate of concern. You can just separate them from that point. Otherwise, you will find other resources. A good example of such a resource, it can come to something like log analytic workspace for your logs. And I believe when you go to the blockchain side of it, there are also such kind of a thing. When you create, you can define. When I define this one is under this subscription, if someone has no access to that subscription totally, or even if you are having an enterprise application, anything. When I say about identity, I talk about people, I talk about groups, I talk about manager identities, I talk about service principles, and all these are the ones which govern your application and how your application will run. So decentralization can achieve right at the top. You see where the level of decentralization is needed, and you implement it at that point.
Okay, so Neville, do you think, are you satisfied? Neville, you can respond if you are satisfied. Okay, so there is no other question. So yeah, so
Okay.
I think we can proceed to the next thing.
Right, just let me share the other slide, as this one is really deploying. Take a bit of time because there are a number of things being deployed at the background, and that is done by the managed provider doing all those stuff. So back to this. So allow me to share on the data flow traffic, and then I'll welcome question on the same. Then in the next 5 minutes, we'll move back, finish up. So in this case, how the data flow happens is that normally you'll go to either your browser there, and then we search from that point. Maybe you're searching moringa.com. That one, the purpose of that, it has been the domain, you're hosting a domain on Azure, it has been achieved using an Azure DNS. So that is where you search for maybe moringa.com. Then, as I said, cloud computing, we're accessing this just over the internet. So this one, it comes through the internet and then comes to the Azure DNS. The Azure DNS, the CDN. On the Azure CDN, it will look, do you have any cache of this content that this person is looking for? But for the first time, of course, the answer is no. It will hit. In a case where we have the front end and the back end, so the front end is totally isolated from the back end. The traffic, it will first hit the front end before going to the back end. And the front end is totally isolated from the DB. There should not be a way where a traffic coming from the front end reaches my back end. Totally, it's not an architecture that we love to come up with. I want to restrict my architecture in a way that the traffic destined to my front end, it will just hit the backend, because at the front end, it will have to go to the right API so that it can get the right data. So there, I have the communication between my front end and the backend alone. And then it is the responsibility of the backend to reach my database. Why? Because maybe there's a query has been made on my DB. So it is only the backend that will go there and search the specific content and get it back to it, and then send it back to the front end and go back to the user. So in case of any attack or in case of anything, this attack will only be terminated at the back end. I want this traffic that comes from the front end to reach my backend, and how I want my backend, my database, only to accept traffic from my backend. So my database, how will this be achieved? There are a number of ways in which you can do this, and how this backend communicates with the database. It is through the connection string. So in this case, a good case in mind, you can use. There's a concept of networking when you come in Azure. We call them VNets. A VNet is just an isolated network that you can have. You see the way you have physical network in your on-prem, you can achieve the same on cloud. And in this case, when you talk about Azure, we call it a VNet, which is a virtual network. Then there are some of the things that we can use, which I'll show you after the deployment has finished. There is something that is called a private endpoint. So as the name suggests, it's a private endpoint. It means that this will only will pull my database inside my VNet, give it a private IP, and allow only access to this DB through a traffic that will come through that private endpoint. So if I have any other backend here, that backend will not be able to reach my database unless I provision a private endpoint. So this one will ensure that all my backend is only, my database is only accessed by the required backend. So in that case, we'll do that. And then it will fetch, it will come back to the backend, front end, back to the user. The user, while connected the second time, since we'll have the CDN in place, in normal case, we'll configure the CDN. In this case, we're not configuring the CDN. So because we don't have the domain names and all those configurations that we have to do. So the Azure CDN there it will see if you have that cached content and get back to the user. The aim of that, as I said, is to improve on the performance by reducing the latency. Okay, and in normal case, we'll have an application gateway or Azure front door. The term here, when we talk about an application gateway, is just to allow we load balance between, if we have a number of the, can have a number of the applications whereby maybe a number of the front end. By having an application gateway, it will load balance the traffic. Maybe if this front end now is handling a lot of traffic, I can dismiss this traffic to another front end. So the load balancing aspect of it, and also the WAF capability. We talk about the WAF is a web application firewall. So this one is protect our application from something like DDoS attack. We want to protect our application from top 10 or security issues. So I don't want something like SQL injections to my application and all those kind of the worst top 10 security issues that we know. So normal scenario, we could have an application gateway there. If we could be doing a production environment, but for our test purposes, we just want to get familiarized with how can I host my application on Azure, and that is the aim. So is there any question that I can handle before we now go and finish up the configuration back then? We want to pull our code now to our apps, our web service, so that we can be able to see how the application looks like. Is there any questions so far concerning this architectural diagram? A point that we love to see how it adds up to this exercise that we are doing. All right, I take that on to be the no. I believe we are all the same point. Now allow me to share back the lab environment. Okay, kindly confirm you're able to see my lab environment. Kidima, could you do that for me?
Yes, we can.
All right. While in your lab environment, so the has been deployed to view our app service has been deployed. Our web service is there. We can see it from this point. But before we view at this point, you want to see what are these services that have been deployed. Since we see that the source group is a container whereby we have all our services in, I believe we can view that from the source group level. So we can go to our source group, and then we go to a source group that has been created there. And these are the various services that have been created. You have seen it has created a app service plan. It has also created an app service. It has created a MongoDB, where Cosmos DB using a MongoDB API. It has also created a private endpoint, the one that I said, which points my backend to that specific database. It has also created a network interface. Why? Because since we have the private endpoint in place, it means that we are having our database sitting in a VNet, and that's where to give it an IP address, a private IP, which it will be assigned on a network interface. Then we are having a virtual network, then a private DNS, because when you configure the private endpoints, it changes on how these services are being retrieved or are being reached. So that's why we have the private DNS in place. So these are the services that have been constructed. Very quickly, we are going to we see our app service. When you go to app service, this is essentially how the app service looks like. No specific good thing that you love about it unless you put there your code. Why? The reason is because when you hit on this default domain, it will open another page. It is still loading. It will open another page. Yeah, and that page is empty. So we'll need to pull the code into this web app. So our code. But before we pull our code, can we have 3 seconds into how our code looks like? So on how our code is, this is the code. Maybe, okay, I'll have to do a lot of resharing of my screen. Let me just open the code and then share with you just a quick one. In the meantime, if you have a question, you can just pull it through. Okay. Let me share my screen. As quick as I can. Okay, in my GitHub. Let me share my screen, but let me see if it has picked my GitHub account. Oh, you're able to see my GitHub account? When I was here, you're able to see my GitHub account. Oh, okay.
Yes,
nice. All right. So I want us to have a look at how our code is structured, because we're going to make a few alterations, come to our configuration, then our connection.js folder. There's something I want to take note of. It is at the bottom here, the connection to our database and the connection to our database name and the database URL. As you can see from these, the way this one has been configured, you see it is a process. Let me just highlight it so that you can all see the reason why you're going to make the necessary changes. So it is, this one is a process dot environment dot database name. So this one is a dynamic variable. This one we have to define it on our application setting. What this means is that as this code will be pulled to the cloud, the name of the database, it will be picked from these. It will be picked from this variable or from this setting. So it will, as this code has been outlining, you want to override the default database name as Azure to do up. We are going to define an application setting that will define our database name. Let me just pick it up. It is a database name. And we also have to define another setting, that is the database URL, because also this one is a dynamic environment variable. So for that, I can copy that. And then in our DB, you come up to our notepad. That one is our database name. We'll configure it. And then anything else that I want to take is how the path to our database has been defined, which is here. Sorry. Okay. So we want the database name. Allow me to pick it. And then I'll also take note of that. I'll take my database name, and then so I've taken it to this one so that I can see what we're going to do on our application, which is this one. So for this, our application, we are going to change a number of the settings before we can pull our code. So to do that, we'll do this one through our deployment, our configuration first. We want to change those things. Just pick some seconds. Okay, and also I had another lab test set for this purpose because it takes a bit of time to pull the code. So in this case, we won't wait for all that time. We'll just use the other one, and we address the few questions that will be there before we call it a day. So for this, you can see under this application setting, there's this connection string that has been defined here. But this connection string is pointing to my MongoDB. But do you remember how we are directing our traffic to the database? It was on our code, it was through, it was database underscore URL. So it's either we change here the name to that database underscore URL, or we go to our code and change where we have the dynamic variable to this one. I'll prefer to go the easiest way, and that's why we're choosing cloud, because it makes work easier. In this case, to make work easier, I'm going to change this. So we're going to change that one. We're going to change on the name. We define it how our code has defined it, and the way the code has defined it, it was database underscore URL. We're doing it quickly, in just a second. We wind up on this. That is a database URL. We want to make that, and then we can save that one. We save. The other thing that we have seen is on the database name. There's a dynamic variable defined as a database name. but it's not under our application setting. So what I will do, I will want to add another application setting that defines our database name. So I'll click there, and then I'll go to my database name. I'll go to my control copy. I'll go to my database name. That is it. And then I'll take the name. Remember, I told you we take note of our database name. So this is when you're going to use that one. Copy, and then we input the value, and then we also save this one. So as we save the various application setting, we now go and pull our code. Our code has to come to Azure so that we can see, because as it sits at the moment, maybe if I can show you this, there's nothing at all here. You're able to see my screen, I believe so. As you can see,
yes,
this is just a container in it, it's running an image, a Docker image, and it's telling you it's ready to wait for your content. So as I said, this one, it was a pass. What you're going to assess ourselves, we're going to assess ourselves on how we're getting their data and our application, and in this case, our code. So the step that you can go through, it is pulling up, and we want to have a CI/CD pipeline in place by using GitHub Action, so that whenever we make a push in our code, that is being deployed in this environment. In normal case, we'll have various slots. We'll have the dev slots and production slots, so that your changes, you see the effect first on the development slots before you swipe it to the production. But in this case, we just going with one slot for the purpose of demonstration, and then you'll go and dig deep into that. In this case, we have the various ways in which you can enable the CI/CD pipeline. I'm taking GitHub. So this one, it will ask you to log in. My case, I've logged in. You log in your GitHub account there, and then from this one, okay, I already have it as one organization. Already pulled up there on. All right, and then on a repository, you will pick the repository where you are. Your code is sitting. Mine is sitting at, yeah, it is a sample code I fork for this purpose. A certain repo forked, this one from the Microsoft one, that is the one. And then here we're going to choose our branch where we want to make the deployment. In this case, we're going to click on main. So that is it. And then when you save, it will take you for a while as it is pulling up the code. So let's finish. So you can observe it, and when you go here, or when you go it from your GitHub, it will show you the various processes. It will take a bit of time. It's doing a build and deploy. That one is, I believe we want to be able to sit in a setting for us to see this, how it's building and deploying. But a good case of this, there's somewhere you can change your workflow file so that you compile all the artifacts that are being uploaded to Azure as one, and that will be very, very quick. So anything that we do, any push that we'll make on your code, on your repo, in this case, I'm using which repo, any push that will make here, it will trigger that build and deploy process. So make any push, meaning that you're making any change in how my application is sitting. And in that case, that is why it is preferred you have two environments, a dev environment and a production. After I make a push, you come and see how your development environment is, if that is well with you, and then you can swipe to the production. But so it will go through a build and deploy process. But for the sake of this demo, it already done so, because I believe we cannot wait in this setting. And for that, we can see what that one intended to deploy. And for this case, just a second, deploy a demo for you as this one, but for this one is deploying a demo. When you can check on the deployment center is what we have. Deployment center, we can come on the settings. We see I've linked to my GitHub. Anything I make change there, any push, it will also affect this way. So to see what that one was to deploy, it was just to deploy a sample Node.js application. Yeah, and this application is using a MongoDB, and anything you can do, you can add something, you can add a task, and anything of the sort. So since you guys are more into development field, you can play around with that, find it sweet on how you can host your applications and on how you can have the CI/CD pipeline in place, rather than you. So the first time it will take a bit of time, but from the second time it just the changes which are being pushed, you just push your repo start a build and deploy process, and you have the changes in the way your application is sitting. And basically, that was the aim of this demo, just to see what it takes you to have a web application hosted on Azure. So I welcome any questions in the next 5 minutes. If there's no any other question, I'll really appreciate taking it back to the moderator. Is there any question concerning what you have asked? Okay.
Yeah. There are some questions here. So the first question, will you incur charges for deploying the application?
Yeah. So what you have said, the payment model in cloud is pay as you go. There's a couple of charges you will incur when you deploy your application. Only those, the charges it will be as a result of what you are using. To see that, maybe before you can come and deploy, I would love to direct you all to, let me open from this point, and I direct you to, it is called Azure. In this case, I'm using Azure, but I believe for any cloud, they have a pricing calculator. This one to tell you an estimate of what you are going to use. So in this case, I'm using an Azure pricing calculator. And then I'm dealing with an application service. And then I'll have to do a bit of estimate. This is loading. Give it a second. Forgive my network. Yeah, adding this one. Already added. Yeah. So we don't want to have these. These are the virtual machine, which is essentially a server. Okay, we wanted to take an app service and go to an app service. Yeah. So this one is an app service. So in this case, I want to see the income. I would love to deploy in North Europe. So North Europe, we go to Europe and see. Okay, deploying in North Europe. This one is going to deploy the Linux because of Docker there. And then I'm going to we use a standard way, but there are various versions, as I said. The various versions come to the various capabilities, such as the one that can enable you to do the VNet integrations, the one that can enable you to do an auto scaling, and all those kind of things. And this one, since it will run on an app service plan. So the app service plan is the one which it will dictate the payment model, the paying that you want to have. So in this case, as a selected standard, I have these three options. So an heavy application is the one that will require something like 3.5 GB, 50 GB of storage and all that thing. But for me, I believe let's use maybe a 2 cores and 3.5 GB RAM. That can be okay for my application. However, I can scale it anytime. So if this application is up 24/7, that is throughout the month, I will incur a charge here. So a charge is $138. But for an organization where it's saying this one, you can stay it for a time, it will depend on the agreement that they come in. They can decide to go with reservation. They can decide to deploy an automation that will do a stop and start. But for an app service, cannot do a stop and a start. That one will really work when you're doing a VM. Maybe you want to consider an IR solution. You can deploy a start and a stop, whereby you can have a few hours here and to use. But for what you have deployed at the moment, what is running, if I leave this one to run for a full month, this is the amount I will incur. So it's a matter of what are you trying to solve. If this is a matter of you testing it on a lab, just the way you have done. So once you are through from this meeting, I will clean up these resources because I don't want to incur this cost. Okay. What was the other question, please?
Thank you so much for responding to that. So I think the other question is whether the session recording will be shared. So the session has been recorded and it will be uploaded. So we will ensure that it has been uploaded so that you can be able to refer to it. So the other question was, is it advisable for someone to enroll for the DevOps course or even join Nairobi DevOps community if they have never done programming? So you can join Nairobi DevOps community. There is no limitation. Anyone can join it. So you don't have to be a DevOps engineer. You don't have to know anything. So you can just join if you are curious. So curiosity is all you require to join the community. And then for you to do a DevOps course, so it will be good if you remember I said, you do not have to start with programming, but maybe you've already started with Linux administration or network engineering or cloud development, or you're a cloud architect or something of the sort. You can shift from that into DevOps. So you don't, programming is one of the things that you can use as a tool to advance into DevOps, but it's not the only option you have. Okay, so I think I've responded to all questions. So, there is another question here. What are the main cloud provider companies in Kenya? Kenya companies only.
We don't have a
So
major public cloud provider.
Yeah.
You want to respond to that? Sorry?
I just wanted to say this is the last question.
Okay, all right, thank you.
Yeah.
There's no an enterprise public cloud provider in Kenya. As I mentioned, the three big in the industries are the Microsoft Azure, the AWS, and the Google Cloud. However, I've tried to say maybe that is a point of clarification you can find from the Safaricom people. They once tried to see if they can they can offer cloud services to the individual. I don't know how that project went, but as I pointed out earlier, for it to be called a cloud, we have the various characteristics of cloud that what you're providing has to achieve. You cannot have a virtualized environment renting out to you and we call it cloud. There's a specific characteristics that it must achieve for it to be called a cloud. As far as that is concerned, we don't have a cloud provider in Kenya. Thank you. Okay, thank you for sharing that. So I think somebody else asked what are the prerequisites for DevOps. So I think it's just the same things I've shared. So either you're coming from a background of networking, Linux administration, you already have a cloud knowledge, or maybe data science. So if you're already in the tech field, most of these things are required. For example, you require networking for DevOps, you require scripting for DevOps, all these things are required. So if you're already familiar with one of them, it will be easy for you to advance from that point. So actually, let me just go through these slides very quickly, and then it will be easy for me to explain that. Or Sasha, did you want to go through them?
No, you can take them through the overview, like the course overview, okay. What's required and when they can join. Thank you.
Okay. So at Moringa School, we have a DevOps course. And what you need is just some fundamental knowledge of software development principles. Like you do not have to be a pro software developer, but you should understand how software works. This is something you can do even before you apply for the program. And then you're required, so you will be having some tests that you will be given for you to do before you can be accepted into the program. So you have to pass that test. So it will just test some skills. So it will check on your background to test if you are fit for the course. And the assessments will be shared with you, I think, on your email. And then the classes are fully online. So you'll be required to be in a position to access a stable internet. And the classes are also conducted in English. So you should be able to understand English as well. And you should have a laptop that is 8 GB RAM at least, and Core i5 and above. So, and that is about the requirements. the course itself is an 8-week course, and it's a part-time class. The classes happen from the classes plus the sessions, everything happens from 6 p.m. to 9 p.m. So the delivery is online, and the instructor-led sessions, and we also have some one-on-ones. We have pair programming. There is more that you can get, and it's project-based as well. So at the end of every 2 weeks, you do a project, and then you'll have access to lectures, live lectures, and also technical support. So the cost is 55,000 Kenya shillings for the 8 weeks. So you can move to the next slide. Yeah, so week 1, we look at Linux administration. And then after that, we look at introduction to DevOps. We look at containerization and Docker in week 3. And then week 4, you automate tests. So week 4, we are still looking at Docker. And then we also look at containerizing tests and automating that. And then week 5, we look at infrastructure as code. We look at a tool called Ansible. And then week 6, we look at we finish up with Ansible, and then we have an introduction to Google Cloud. Week 7, we continue with Google Cloud, and week 8, we do orchestration, that is Kubernetes. So that is about the course. So at the end of the course, you should be able, actually week 2, where we are doing introduction to DevOps, we are also doing Git and CI/CD. So week 1, we are doing Linux administration. Week 2, we are doing Git and CI/CD using a tool called Jenkins. So by the end of the course, you should be able to create your own pipelines. You should be able to deploy cloud-based software applications. And yeah, so you should just understand the entire DevOps cycle. So when you're learning about the cloud, you also introduce you to monitoring. So you'll have the knowledge of the entire DevOps cycle, and we give you working software that you use. So that is the reason why maybe it's not a must for you to have a background in programming, because the code that you are given to work with as a DevOps engineer has already been created. So it has already been created for you. So if you are coming from any other discipline, it will be possible for you to still learn, and then you can learn a scripting language later. So you can go to the next slide. So you visit our website to apply, that is moringaschool.com, and then under there, you can click on courses, and then you click on DevOps engineering, and then you can apply from there. So you can share that link in the chat if possible as well. And then, so what I've just said, you'll have some technical assessment after you've applied, and after you are accepted, you can join the program and meet us on the other side. So I think that is it. Do you have any questions? Is there any other slide remaining?
I can take it up from here.
Oh, okay. Go ahead.
So,
okay, go.
Thank you so much, Samuel. So you've heard about our course and how you can join. So we don't have scholarships for this program because it is fairly priced, right? So what you can do, because the next intake starts on September 4th, you still have a bit of time. You can apply once you get your acceptance to the program. Just start paying pole until the start of class. Hopefully you would have finished the 55,000 to be able to join. So we require you to pay the fee before start of class, and for you to book your slot, because you have a very lean and small intake, small numbers for each intake. We encourage people to make a commitment. So even if right now you apply and you don't have the full 55, just pay the amount that you have, maybe 10K, and then you make sure you complete it by September 4th. Then the other financing option is student loans. We work with Aspira. to provide students with loans at almost negligible like interest rate. It's like 1% interest rate. Yeah, if you look at the calculation. So if you want to get this student loan, apply, get the acceptance letter. Then our admissions office, you inform them that you would like the student loan. They'll be able to share with you the form, all the details that you need to provide, like, we need to screen your credibility, if you're eligible for loans, and then Aspira will be able to process that, pay for you, and then you pay them after you are done with the course within a certain period. I think you have like a payment plan that's within a year for you to pay that back. Yeah. So first things first is make the application. Then our admissions representatives will be able to just assist you with all the financing options that we have available. Yeah, so the next intake, like I said, is on September 4th. We don't have another intake for the rest of this year, maybe until January next year. So we highly encourage you. If at all you want to get, certified as a DevOps engineer, maybe you're pivoting from another career, maybe it's a certification and skill that you want to add to your portfolio, highly encourage you to, take the time, sign up for our program and learn and earn your certificate. Yeah, so that's pretty much it from us. I don't know if there are any other questions. I saw some questions around the program at the start, but I believe they were answered. Yeah. So if at all you have any questions on Moringa School, please feel free to ask. We still have a bit of time. I'm happy to take your questions before we go to the end. Any questions regarding Moringa School? Okay, great. If there is none, please, I've shared the feedback form with you on the chat box. Kindly give us your feedback. Tell us how you found this session. Your feedback helps us curate better and better webinars, workshops, events in the future. So we'd like your feedback. Let us know how you found this. Give your remarks also to the facilitator. We'll share with him how you guys rated him. I know he was amazing. Thank you so much, Albert. And then let us know if you have any other questions for us. If at all you need assistance on like your application, feel free to email us at admissions@moringaschool.com. Send us an email there, or you can DM us on any of our social media platforms. At Moringa School, we are on Twitter, Facebook, Instagram, TikTok, LinkedIn. We are everywhere. So if at all you face a challenge with your application, feel free to reach out to us. We've left the contact details on the chat box, or DM us, and we'll be able to assist you. All right, so I think we have come to the end of our workshop today. For me, I'd just like to say thank you so much to everybody who joined today. I know we started a huge crowd, but some people have dropped off maybe because of internet and the like. But we want to thank you so much, all 80 plus of you who joined today. Thank you so much for staying through to the end and learning with Moringa. Huge thank you to our partners, DevOps Nairobi community. Thank you so much for working with us in making this workshop a success. Then I'd like to thank our facilitator, Albert. Thank you for sharing your expertise and knowledge with the team. I'm sure you're going to receive so many LinkedIn requests after this for people who would like mentorship or guidance or like a follow-up. Feel free to reach out to Albert Sitati on LinkedIn, also Samuel Kadima on LinkedIn, and join the DevOps Nairobi community to continue learning and growing. From myself and the team that was working behind the scenes, yeah, I just want to say thank you so much and wish you guys an amazing weekend. I hope to see you in our classrooms, in future events. Yeah, just be part of the Moringa community as well. Okay, thank you guys and have a good weekend.